Okay, so as you look at this paper right here, these two bigger triangles, are these two bigger triangles congruent to each other?
No.
Is this triangle right here congruent to this triangle?
No.
How do you know?
It's shorter.
Right is bigger.
Okay, so what I want you to do is cut both of them out. Cut both of them out and let's see if they're congruent to each other.
Okay, they are. It's a brain game. What would you do?
I watched
What should be the same?
That's what we just said.
Oh, sorry.
Cut them out as nicely and neatly as you can.
I don't know why I've done that class. I don't know.
You have all the above, everything from A to Z.
I don't even know what.
How do you know you don't have it? This is what you have. You don't need to do it.
Okay, are they congruent to each other?
No.
Okay, so we'll take these, stack them on top of each other. Are they congruent? Are they exactly the same? Nope. You can see how one of those is a tiny bit smaller than the other one.
Wow.
Okay? So the answer is no.
So we gotta cut out our test, is what you're saying.
These are not congruent. Okay, and so that's good. Because no, I'm not saying you're going to cut out triangles on your test. You're going to use the stuff we're going to talk about today to determine if they're congruent or not. Okay? All right, now let's think about these right here.
No.
Are those two congruent?
No.
Yeah.
No.
Okay,
No, because
cut them
that
out.
one- That one, the left one is 90 degrees.
Cut them out and let's see.
The one that's not a right angle is a right angle. I think I'm just wrong.
Cut them out and let's see if they're congruent or not.
They're not. One's a right angle.
And again, cut them nice and neat. With good crisp edges. Crispy edges.
Then again. Oh, they are.
Jordan, you better be playing.
They're congruent.
No, they're not. You better give me scissors back in World War II.
Yeah, you did get the janky scissors.
Just so you can say that every morning.
Oh my gosh, they are. Ooh.
I told you.
Is it the same?
Yeah. My brain tricked me.
Brain games.
See, whenever you cut it out, everything you
Ah.
do, let the right do it.
So what he's saying is,
Okay, so I'm gonna fill this.
That's all an illusion, and we.
I need to watch more brain games episodes now.
Okay, are those two congruent to each other?
Yeah.
Yes, they are. Okay? Those are congruent. And we can see that because we can cut them out and like set them on top of each other and see with our own eyes, yes, they are congruent.
And we do that for the test.
Okay, now, on the last two right here,
No, they are not.
are these two congruent to each other?
No, one's a ramp, the other one's a pyramid.
Nope. There's no reason to even cut those out. I can look at that and tell you for sure. Like, no way. There's no way those two are congruent. All right.
I was already cutting them.
I don't want it. Because I already know it's that. Look.
Okay, so that's going to lead us into what we're going to talk about for today.
Can I throw these away?
You can throw them away in a little bit. All right, so yeah, y'all brought up a good point. So when you're taking the test, how can you tell if the two are congruent? And no, you're not going to have scissors on your test to cut them out and see. So, well, no, this is not going to be ghetto. This is going to be smooth the way we're going to do it, okay? So we've got different ways to prove if triangles are congruent. And we briefly just mentioned them in our vocabulary that we did on Monday, where we talked about all those different SSS, SAS, and there's a bunch of different ways to prove two triangles are congruent without having to cut them out and do like what we did right here. Now, there's some of these ways that will work, and there's going to be some ways that'll seem similar that don't work. We're going to talk about 2 ways to prove triangles are congruent today. Now, one thing we need to define here is included angle, and I forgot, I didn't put this on your vocabulary from the other day, so we need to get this defined here. Okay, so included angle is the angle formed by 2 sides of a polygon. Okay? It's the angle formed by 2 sides of a polygon. And so in general, that's what it is. We're going to be talking about it as it relates to triangles through this unit, but included angle is the angle formed by 2 sides of a polygon. So what I want here is just to list the included angle for these sides. So you can see here AB and BC. So here's AB, here's BC. So what is the angle that's formed by those 2 sides? I mean, what's the name of it? No, not its description, but its literal name is angle B here. Okay?
Should have just kept saying right angle.
There you go. Yeah. So it's angle B is the included angle for those 2 sides. Okay, what's the included angle for side DE and FE?
Angle E.
Here's DE, here's FE. What's the included angle?
Angle E.
Here's angle E. Okay, what's the included angle for QR and RS?
R.
Is angle R. And then what's the included angle for angle MN and MP? Okay, is M. Okay, now, really we could see that without even having to look at a picture. How could you tell what the included angle is?
The only two letters.
It's the point that they share. It's the vertex of those 2 segments. So you can see there's a B in both of those. Angle B is the included. Here, E is included on both of those. That's where they're going to meet up. That's going to be the included angle. Okay, R and R. And then M and M. That's the included angle. Okay, so we don't need that for SSS. We need it for side angle side. So we'll get to that in a second. Okay, so on side, if the sides of one triangle are congruent to the sides of a second triangle, then the triangles are congruent. Okay, and then obviously the abbreviation we'll use for that is SSS, side. Okay, so let's start off. So side AB is congruent to what?
AB is congruent to
ZX.
To ZX, good. Okay, BC is congruent to what?
XY.
To side XY. And then side AC is congruent to what?
ZY.
To ZY. So what I'm going to say now is by SSS, triangle ABC is congruent to triangle what? CXY. Okay? So if I knew those three things, if I know that this side, AB is congruent to this side, ZX, that BC is congruent to XY, and that AC is congruent to ZY, that's all I need to know that these two triangles are exactly the same, that they're absolutely congruent. So if I knew that about these two triangles, I wouldn't have to cut them out and stack them on top of each other to see if they're congruent. If I knew this right here, I could tell you for sure they're exact same triangles. They're exact same thing. Okay, next one. Side angle side. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Okay, and so our abbreviation for that is SAS, side angle side. Okay, and this is the included angle. That's important to know that. So this angle right here is going to be the included angle of those two sides. It's the angle made by those two sides. All right, so side AB is congruent to what? To what? Remember, the order of the letters matters here. So AB to FD. Notice that A doesn't have any angle marks, and it goes to the one that does have one. So over here, we've got to go from the one with no angle marks to the one that does. So A to B, it's got to be F to D as we list it here. Okay? Next thing is that angle. So angle B is congruent to what? To angle D. And then side BC is congruent to what? Okay, side DE. Now notice here real quick, this angle B and angle D. You can see how those two are the included angles of the two sides that we're talking about here. You can see how it's the one between those sides. All right, so what I'm going to say now is by side angle side, triangle ABC is congruent to triangle what? FDE. Okay, so again, if I know this about these two triangles, where you have this set, these two sides are congruent to each other, these two angles, and then these two sides, that's all I have to know that these two triangles are exactly the same. I wouldn't have to cut these two out to put them on top of each other. I know that they are going to be congruent to each other. Okay? So when you're taking your test, no, you don't have to cut it out. If you know this information, you'll know they're exactly congruent. Okay, down here we're going to do a proof. So let's make a little T-chart here basically. This column, we're going to write our statements. Over here, we're going to write our reasons for why that's true. Okay, so what do we generally put on the first line of our proofs? Yeah, what's given to us, right? So I'm going to go ahead and I'm basically just going to split this in half here. So I'm going to say EI is congruent to FH, and I'm going to say FE is congruent to HI. Okay, and how do I know that's true? Because it's given. Now what I want to do is I want to mark that information on the picture here. Now, the first thing it tells me is that EI is congruent to FH. And that's going to be kind of hard to mark on here because G's out in the middle and it's going to kind of make a mess of this. So we'll just keep that in the back of our minds, but we can mark this, and this is important right here. So FE is congruent to HI. So here's FE, here's HI. Those two are congruent. So I'm going to mark that like this. That is congruent to that. Okay, so that's that little piece right there that we just marked on there. And again, I know that's true because it's given to me. Okay, for our second statement. All right, and I'm just splitting this up just so it doesn't kind of run together. We can see them separately. The next thing is that G, and I'm going to abbreviate a lot here. I'm going to say G is the midpoint of EI and FH. G is the midpoint of EI and FH. So again, how do I know that's true? Yeah, right there. That's given also. Okay. Now, let's think what it is they're wanting us to prove. What do they want us to prove here?
The triangle FEG.
Okay, so they're just wanting us to show that these two triangles are congruent to each other. All right, so that's where we're headed. Now let's go back and think about number 2 here. It says G is the midpoint of EI and FH. So G is the midpoint of EI. What does it mean for G to be the midpoint of those two?
Right in the middle.
Good. It's exactly in the middle.
Those two are the same.
Good. And so if G is exactly in the middle, I know that this segment from E to G is the same length as it is from I to G. So let's mark that. I know that this piece and this piece are congruent to each other. All right? And it says that G is also the midpoint of FH. So if G is the midpoint of FH, what do I know about these two segments?
F and G is the same as G to A.
Okay, good. So those are congruent. Okay, and I know really that FG should be congruent to EG, but we're going to do it that way so it'll be clear in your minds what's going on here. So, because G is the midpoint of FH, I know that this segment and this segment are congruent to each other. All right, so we need to write out what we just drew on there. So we said EG is congruent to what? To IG. Yep. And the other thing we marked is that FG is congruent to what? To HG. Yep. Now, how do I know that's true? Okay? I know that's true because I was applying what a midpoint is. Okay, so right here, I know that's true because that's the definition of midpoint. That's what a midpoint does. That's what it is. Okay. Now, I'm trying to prove these two triangles are congruent. Do I have enough information up here now to prove those two triangles are congruent to each other?
Yes.
Yes. By which one of these? Good. By the first one we talked about. Because if you'll notice here, we have one set of sides, a second set of sides, and a third set of sides. So I have all the information I need now to say that triangle FEG is congruent to triangle HIG. Okay, and what's my reasoning for why that's true? Good, because of SSS. And we're done. Okay, on the back, So on this one, it's filled out a little bit more for us here. So what am I going to put under for that number 1 there? Okay, so what am I going to write? And QD is congruent to AU. There you go. Okay, it's true because it's given. Now, is that information already marked on the picture for me? Yep, it's already up there, so we're good. Okay, now let's think about this. Just using common sense here. If I were to take and split these two triangles apart, where this triangle here, okay, where this triangle keeps this side, and then where this triangle keeps that same side, what's going to be true of that side? Yeah, just common sense, it's obvious that that side is going to have to be congruent to itself. Okay, now that's common sense, but that's also applying this property right here. We talked about this a couple weeks ago. The reflexive property just basically says that anything is congruent to itself. So what I'm going to do here on 2 is I'm just going to write what we drew up there. And that is that DU is congruent to side UD. All I'm doing here is just saying that that side is congruent to itself. Okay, do I have enough information up there to prove that these two triangles are congruent?
Yes.
Yep, I sure do. I've got it all marked. So now I can say triangle QUD is congruent to triangle ADU, and that because of the side, 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 and we're done. Okay, so on these first 3, we're going to say if we can use SSS or not. Could I use SSS to prove these two triangles are congruent?
Yeah. No.
I only know this, that's one S, and I know this S, but I don't know anything about the third set of sides there. So no, I could not use SSS to prove those are congruent. Okay, they may be congruent, but they may not. I may cut those out, and they may not line up with each other. Okay, on this, could I use SSS?
Yes.
Yes, applying that reflexive property, I know that side's going to be congruent to itself. So we have S, S, and S. So yes, we could use SSS here. Could I use SSS on this one?
No.
Right. Applying the reflexive, I know that side's congruent to itself, but then I don't know anything about that third set. So no, I could not use SSS here. Okay, next ones. Can I use SAS? Could I use SAS to prove these two triangles are congruent?
No.
Okay, so we need to think about this one a little bit.
Oh, yes.
Okay, so obviously, if I tell you that, the answer is going to be yes. Okay, think about it. Are these two angles congruent to each other? Yes. How do I know those two are congruent?
They're vertical.
Because they're vertical, and what do I know about vertical angles? They're always congruent. Okay? So we have side angle side here. We have this two sides and its included angles. So yes, you could use SAS here. Okay, could you use SAS on this one?
Yes.
And the answer is no, okay? So the reflexive property says that side's congruent to itself and that this side is congruent to itself, but this 70 is talking about this angle down here. Is that angle the included angle of those two sides? No, the included angle would be this one right here, the one between those two sides, or the angle that those two sides make. So on this one, the answer is no. You could not use SAS for this one. Remember, it's got to be the included angle. It's got to be the angle between those two sides. And then on this one, could I use SAS?
No.
And the answer is nope. All I know is angles on this one, nothing about the sides. All right. On this one, SSS or SAS? SSS. Okay, on this one, SSS or SAS? SAS. On this one, which one? It's SAS. Reflexive, that side's congruent to itself, side angle side. And then on this one, what would it be?
Oh, wait.
Yeah, SSS. So remember, what we're doing with this is we're saying we can use these two to prove if two triangles are congruent or not. So in other words, again, we don't have to cut them out to lay them on top of each other to see if they're the same. If one of these two things is true, I know the two triangles are congruent to each other.